This is the main display of the booster system. It features a minimalistic design, providing easy access to the information you need to run the booster system. In the upper left-hand corner, you will see the two pump icons indicating the pump status. Green on the pump indicates that the pump is currently running. A gray pump icon means that the pump is not running and no faults are currently active. A red icon would indicate that the pump is currently in a fault condition and is unable to run. Below the pump status icons are the off-auto switches. Pressing the switch will change the pump from an off status into auto. Taking a pump from auto to off when it's running will turn it off and bring on the other pump as required to meet demand of the system. Below the off-auto switches is an indicator of pump speed. Fully gray means that the pump is off, and fully green would indicate that the pump is running at full speed. On the right-hand side are indicators of discharge pressure, suction pressure, and a couple of system navigation buttons. Pressing the system information button will bring you to a page displaying additional information about the system, such as runtime, frequency, start-stop cycles, and total energy usage. On this page, you can get a more accurate indication of frequency as displayed by these numbers. Pressing the power usage details button will take you to some more informational pages showing information like motor voltage, motor current, and current power. When taking the pumps from off to auto, the lead pump will turn on and increase in speed to carry the system load. Currently, the discharge pressure set point is 20 psi. Pump 1 has come on to about 3/4 speed and is maintaining the set point. As system load increases, the lead pump will increase in speed to meet that demand. I'm opening a discharge valve to simulate an increase in demand. As you can see, pump 1 increases in speed to meet that demand. As I continue to open the valve, pump speed will continue to increase, and eventually, pump 2 will turn on. When the leg pump turns on, it will increase in speed as the lead pump decreases in speed until they are both matched and modulating at the same speed to meet the demand. Now, both pumps are running at the same speed, achieving the 20 psi discharge pressure set point. If I press the system information button, we can see that both pumps are now running at about 52, 51 hertz. As demand increases and decreases, both pumps will change in speed together. Now, for the leg pump to turn off, a couple things could happen. First would be the normal shutdown method. Periodically, the system will do a check to determine if it's able to turn off the next pump. To do this, it will raise the speed of the lead pump and drop the speed of the leg pump to see if the lead pump can assume the demand of the system. Another thing it does when this occurs is check the power usage. To look at that, I will go to the system information page again, and then the power usage details. We can see that the system is currently drawing about 1.8 kilowatts. Returning to the main page, we should soon see the pump start to turn off. The delay on the system is typically about 1.5 to 2 minutes. Now we can see pump 1 decreasing in speed with pump 2 raising in speed. We'll now perform the checks to determine if it's more efficient to turn off the pump and then turn it off. Going back to the system information screen and then the power usage details, we can see that The power usage is now about 1.2 or 1.3 kilowatts. For the last pump running, it uses a different method to destage that pump. I'm now going to shut the discharge valve entirely. When there's no flow, the system will periodically raise the discharge pressure set point and then hold it at the higher value to determine if there's no flow. In this case, it's set to perform that check every 30 seconds and raise it about 4 psi when doing the check. The default values are a little bit longer than that, but I have it short for demonstration purposes here. Now, you can see that the pressure has increased up to 24 psi, and it's going to hold it there for a few seconds. And when it drops the set point down to the regular value again, it will shut off the pump. Next, I'm going to talk about alarms and troubleshooting of the booster system. To bring in an alarm, I'm going to unplug the discharge pressure sensor. When the alarm occurs, the screen pops up on the main display. On this screen, you can see a number of different things. At the top is the name of the alarm, discharge sensor fault. Below that are indications of the date, time, and count of the alarms. The count is the number of times that the alarm occurred without being acknowledged. Towards the bottom left, you can see that orange active light bulb icon. That indicates that the alarm is currently active. When it's inactive, it'll be shown with a gray icon. In the details box, the name of the alarm is again shown and some text saying to press the hand icon for more details. The hand icon is located up here. When pressing that button, you are taken to another screen that shows additional troubleshooting information. This troubleshooting information includes some basic steps to attempt to get the system running again, often including pictures. Returning to the main screen, you can now see a couple changes on the display. First, for this alarm, the pumps are locked out and prevented from running. So they are now indicated with a red status icon. And in the upper right-hand corner is an alarm dashboard showing all currently active alarms. Alarms will cycle every 5 seconds if there's more than one alarm. Pressing that text will take us back to the main alarm page. This alarm page shows all currently active or inactive alarms. Active alarms are indicated with the orange light bulb. Gray icons are indicated, or inactive alarms are indicated with the gray icon. To clear an alarm, to clear an inactive alarm from this page, you would press the magnifying glass button, which will take the screen to the alarm page that initially pops up. Then press the acknowledge button to acknowledge the alarm. It will look for a password. Password for acknowledging alarms by default is 1111, and then press the return icon in the lower right-hand corner. That will acknowledge the alarm. Now, when returning to the active alarms page, only that discharge sensor fault alarm still is shown. To view the alarm history, press escape 2 times, then go to the operator settings page. That page requires a password as well, which is also 1111 by default. Then press View Alarm History. This page will show up to 256 previous alarms. You can see information such as the name of the alarm, and then this trigger rise and trigger fall. Those mean the time the alarm came in and the time the alarm cleared. You can also see the total duration of the alarm and the time that the alarm was acknowledged, as well as how long it took before the alarm was acknowledged. The up and down arrows at the bottom of the screen can be used to scroll through the alarms. Pressing escape takes us back to the operator settings page. It is also possible to reach the active alarms page from this screen by pressing the View Active Alarms button. All of the alarms will clear on their own when the condition clears, with the exception of one alarm, which I'll talk about later. So when I plug the discharge pressure sensor back in, that alarm will clear and the system will resume normal operation. Finally, I would like to talk about booster system startup. Startup is very simple, and typically all the necessary parameters are pre-programmed at the factory based on the takeoff sheet submitted with the order. First, you would want to check that the discharge pressure set point is correct. To do that, press Operator Settings, and then enter 1111 for the password. Next, change the discharge pressure set point by pressing the number field and entering the new value. In this case, I'll enter 20 psi and press Return. Then, you want to check the alarm settings. To do that, first press Main Screen, then press the Advanced Settings button, located towards the lower right-hand corner of the page. The password for this page is 2222. Then, press the Alarm Settings button in the upper left-hand corner. First, you'd want to adjust or verify the maximum discharge pressure set point. This alarm will occur if discharge pressure increases above that set point value. Typically, we recommend a value of 10 to 15 psi above the set point. The alarm will only occur after the delay set in this field, max and min pressure alarm delay. Below that is the minimum discharge pressure alarm set point. That alarm will occur if all pumps are running at full speed and pressure falls below that set point value. It is effectively a pipe burst detection alarm. Generally, we recommend a set point value of 20 psi below the discharge pressure set point. Below those alarms is the minimum suction pressure alarm. That alarm will occur if the suction pressure drops below that set point value. Currently, I have it set to negative 4 psi, which effectively disables the alarm because I'm feeding from a tank. In that case, if you wanted to use a float switch or other device, it is possible to switch to using a digital switch as a sensor. To do that, you would simply toggle this alarm, or this button at the bottom of the page from analog suction pressure input to digital, and it would allow you to use a float switch for low suction pressure detection. Those are all of the major settings that would need to be adjusted or verified during a startup.